Hey guys, it's Miss Maneely, and I'm going to give you a brief tutorial on factoring quadratics. We're going to start by looking at an equation that's already in factored form. So if you look, we've got y equals the quantity x minus 2 times the quantity x plus 6. If we wanted to write that equation in standard form, then we're just going to perform the order of operations, which typically tells us to go ahead and deal with what's inside the parentheses first, which I can't really do anything about because x minus 2, since I don't know what x is, I can't simplify. I can't really simplify x plus 6 either. There are no exponents. So the next step would be for me to do the multiplication. And when you're multiplying two expressions like this, we have to distribute. And the method that we're going to use when we distribute is what you might call FOIL, the FOIL method, where we distribute the x term first, or the first x. And so that first thing I multiply by, we call those the first terms. And x times x is going to give us x squared. If I continue to distribute the x in the first quantity to the 6 in the second quantity, then that gives me a 6x, and it's positive. I then want to distribute the negative 2. And so now I'm distributing my inner terms. So x squared, that is my f. Those are my first terms. The 6x would be my outer terms, because both the x and the 6 are the outer terms. If I multiply the negative 2 times x, those are considered my inner terms. And that's where the I comes from. And then I also need to distribute the negative 2 to the 6, and that gives me a negative 12. That's my last term. And so that's why we call it the FOIL method. But it's really just an extension of the distributive property. Whenever you're multiplying a quantity times another quantity, you need to make sure that each term in those quantities is multiplied by the other. And to continue writing my equation in standard form, I want to group any like terms. And so I've got the 6x and the negative 2x that I would call like terms because they both involve a single factor of x. No other terms can be combined. When I put them together, my equation then in standard form is going to be x squared plus 4x, since 6x minus 2x is 4x, minus 12. And now my equation is in standard form. So our goal today is to start with an equation that's in standard form and write it in factored form. And the purpose of doing that is that it will make the equation much easier to solve. And we'll talk about solving these equations in another unit. But for now, we're just going to try factoring. And so what you might notice is that these two inner terms that I'm looking at, if I think about the relationship between them, notice that when I add them together, 6 and a negative 2, when I add them together, I get 4. So the sum of the numbers is my B term. And think about what happens if I multiply them. A positive 6 times a negative 2 is going to give me a negative 12. And notice I'm just looking at the coefficients there. And so the product of those coefficients gives me my C term. And we're going to see that some of these expressions are going to be a little bit different. For example, in this case, my A value is just 1. And so the product is just going to be equivalent to C alone. But we'll find that if my A value is something other than 1, then the product that I'm interested in becomes something else. So we're just going to start right now with trinomials that have a coefficient of 1, a leading coefficient of 1. And we're going to talk about how to factor them. Let's make sure that we understand some basic terminology, though. So the expressions x minus 2 and x plus 6 are called binomials. And we call them binomials because they have two terms. The expression x squared plus 4x minus 12 then would be considered a trinomial because there are 3 terms. And so when it comes to factoring, there are several different processes that we're going to use, and those processes are actually going to depend on how many terms our equation involves. So today we're going to be transforming equations that are written in standard form into factored form. And the purpose of that is because the factors are going to correspond to the x-intercepts of the graph, and those x-intercepts are going to correspond to our real solutions. But again, we'll save that for a different lesson. Note that not all quadratic equations can be factored. And if you think about it, so let's take numbers for example, because you probably remember doing this in elementary school. If you have, for example, the number 36, you may have been asked in, I don't know, 3rd or 4th grade to do a factor tree, where you basically take the 36 and you think of all the things that multiply to give you 36. So maybe you think 9 times 4. Well, notice the 9 and the 4 can continue to break down. So with the 9, we might say, oh, well, that's just 3 times 3. And 4 can be broken down to 2 times 2. Now what I've done is I've found all of the prime factors of 36. And so I can rewrite 36 as 3 times 3 times 2 times 2, or 3 squared times 2 squared. And this is essentially what we want to do with quadratics. And along the lines, we're going to end up doing this with polynomials as well that involve more than 3 terms. But sometimes you get a number, for example, like 7. If you try to do a factor tree with 7, the only way you can break it down is by 1 times itself. And so we define a number like this as prime. And so just like with numbers, there are some polynomials or some quadratics that can't be factored. And when that's the case, we call them prime. Okay, so the first thing we want to always look for is if there's something in common that can be factored out or divided out of the expression to simplify it a little bit. And so it says to factor out common terms, we want to do that if possible. A monomial is an expression that involves only one term. And when we're talking about the terms, we're talking about the things that we're adding and subtracting. So for example, in letter A, there are 2 terms here. In letter B, there are 3 terms. And in letter C, there's only 2. So a monomial means that we're dealing with an expression that has 1 term. As a first step to factoring, we should always see if there's something in common. So if I take a look at example A, I can see that, let's deal with the numbers first. If I look at my 3 and my 12, I think, well, both of those numbers are divisible by 3. So I want to factor out a 3, and I'm essentially just dividing it out. I also notice that both of those terms involve x's. I want to pull out as many as I can. The first expression has 4 factors of x because x is raised to the 4th power. The second expression has x squared, which means I have 2 factors of x. So the most I can pull out are 2 factors of x, or x squared. And when I do that, I'm essentially just dividing that out. Whoops. I'm dividing out the 3x squared. So if it helps, on the side to think, okay, so I'm going to take my 3x to the 4th, and I'm going to divide that by 3x squared. And if you think about it, my 3's are going to end up canceling. If I've got 4 factors of x on top and only 2 on the bottom, well, 2 of those factors are going to cancel. So that leaves me with an x squared. I'm subtracting, so I'm going to bring that down. And then I've got to factor the 3x squared out of the 12x squared. Well, let's do the same thing again. If we have 12x squared over 3x squared, I know that 3 goes into 12 4 times. And since both my numerator and my denominator involve an x squared, those x squares are going to cancel. And remember, when numbers cancel, they cancel to 1, not 0 when you're dividing. And so finally, we're going to have x squared minus 4. Now this expression can actually be factored a little bit further, and I'm going to show you how to do that in a second. But that's what I mean by factoring out a common term. If we take a look at example B, I'm going to look first at my numbers. I've got 7, negative 14, and 21. I know that all of those numbers are divisible by 7, so I can factor out a 7. I also note that all of the terms have an x, which means that I can pull an x out. And so if I factor out an x, that means that what's left in that first term, since I'm dividing out a 7 and an x, that leaves me with x squared. In the next term, if I divide out a 7 and an x, 7 goes into negative 14, negative 2 times. And if I factor an x out of x squared, I'm left with a single factor of x. And then if I've got 21x and I want to divide out a 7x, I know I'm just going to be left with 3 because the x's are going to cancel. In the last expression, the only thing I can pull out is a 9. And when I do that, I'm left with 9x squared minus 1. And again, we do want to be able to see if those expressions that are left within my parentheses can be factored any further. And in some cases, they can. So the next step to factoring is to count the number of terms and look for patterns. So if we've got two terms, for now, we're going to be talking about a pattern that's referred to as the difference of squares. And to introduce difference of squares and help you understand where it comes from, I want to take a look at these three examples. So we've got an x minus 2 and an x plus 2 that I'm multiplying together. In letter B, I've got 2x plus 9 times 2x minus 9. And then in letter C, it's 5 plus x, 5 minus x. So hopefully you can see that in each of these expressions, the quantities are almost identical except for the sign. One's plus, one's minus. And let me show you what happens when we FOIL out and write these expressions in standard form. So when I multiply the first terms, I get x squared. X times 2 is going to give me a positive 2x. If I distribute the negative 2, that's going to leave me with a negative 2x and a negative 4. And notice that these middle terms are going to cancel, so I'm just going to be left with x squared minus 4. If I do the same thing with the next expression, 2x times 2x is going to give me 4x squared. 2x times negative 9 is negative 18x. If I multiply my inner terms, I get a positive 18x and a negative 81. Notice again the middle terms cancel, and I'm left with 4x squared minus 81. So notice in both of these cases, those middle terms are canceling. And that's because of my opposite signs here. Because one's positive and one's negative, my middle terms are always going to cancel. Let's do one more. This time I'm going to do 5 times 5. I'll distribute the 5 first. This gives me 25. If I distribute the 5 to the negative x, I get negative 5x. And if I distribute the x, I'm going to have another positive 5x. And x times negative x leaves me with a negative x squared. My 5x's cancel, and I'm left with 25 minus x squared. So, like I said, this pattern is called the difference of squares. Let's think about where the name comes from. If you take a look at each of the terms in these binomials, they are both perfect squares. 4x squared is a perfect square, 81 is a perfect square, 25 is a perfect square, x squared is a perfect square. And notice that the operation that I'm using is subtraction. That's where difference comes from. And so we actually have a pattern. If I am subtracting two perfect squares, so we're talking about the difference of squares, then I can easily factor it by taking the square root of each of those terms. So in this case, the square root of a squared would be a, and the square root of b squared would be b. And subtract them and multiply that by the sum. And it doesn't matter the order that you write them. I could do a plus b times a minus b, and I get the same thing. So let's take a look at some examples. Now we're going to go the other way. So if I wanted to factor x squared minus 16, I can see very clearly that both of those numbers are perfect squares. In this case, my a would be the square root of x squared, which is just x, and my b term is going to be the square root of 16, which is just 4. And so following my pattern here, I'm just going to do a minus b, which is x minus 4, times a plus b, x plus 4. If I look at number 5, again, I can see that both of those numbers are perfect squares, and I'm subtracting, so it follows this pattern. My a value in this case is going to be the square root of 1, which is 1. And my b value, notice that I'm ignoring the sign because the sign is actually part of my formula. My b value then is going to be the square root of 4x squared. So I need to take the square root of 4, which is 2, and the square root of x squared, which is just x. And so using my formula, it's just going to be 1 minus 2x times 1 plus 2x. And lastly, we've got 25x squared minus 49. Both of those terms are perfect squares, and so if I take the square root of my first term, I'm going to be left with 5x minus 7, since 7 is the square root of 49, and 5x plus 7. And that's how you factor difference of squares. We also have a property for sums and differences of perfect cubes, but that's something that you'll learn in Algebra 2, so I'm going to skip that for now. And I'm going to jump to expressions that involve 3 terms. These are trinomials. And so we're going to first look at trinomials where that leading coefficient is 1. And so again, a trinomial is going to look like this, where we have y equals ax squared plus bx plus c. And so that's where my a, b, and c's come from in these rules. And so our goal is to figure out the 2 pairs of binomials that will multiply to give me this trinomial. And so when a is 1, it's actually pretty simple because the coefficient is 1. And so what I'm looking at is the product, 2 numbers that are going to multiply to give me this term here, negative 28. and that are going to add to give me negative 12. And so I always do a little t-table. Some of you are going to be able to notice the pair right away that works. Others might need to do a little bit of trial and error. And don't be afraid to make a mistake. So what I'm going to do is I'm going to think about numbers that multiply to give me negative 28. So I might think, okay, I know 7 times 4 is going to work. And because 28 is negative, one of these numbers has to be negative so that when I multiply, I get a negative number. So I might try negative 7 times 4. And I might then also try 7 times negative 4. I might try 1 times 28, or negative 1 times 28, or 1 times negative 28. And then I think there's one more pattern. How about negative 2 times 14 and positive 2 times negative 14? And the goal is to figure out the pair of numbers that when added together are going to give me negative 12. So when I add the first two together, I get negative 3. That's not going to work. 7 minus 4 is a positive 3. Negative 1 and 28 is going to leave me with 27. The next one is going to be negative 27. If I do negative 2 times or plus 14, I get 12. And then finally, I get the negative 12. So notice here that it took several tries for me to find the right pair of numbers that will multiply to give me negative 28, my C term, and add to give me that middle term, B. So if we think about this as unfoiling, when I rewrite my trinomial, it's going to be basically a product of two binomials. And think about factoring. When I multiply my first terms, I need to end up with x squared. And so I need to make sure I have an x here and an x here. I also know that when I multiply my last terms, I need to end up with negative 28. And so I'm looking for the pair of numbers that did that. And it was a positive 2 and a negative 14. And so those two numbers multiply to give me negative 28. If I were to continue foiling to get my inner and outer terms, so I'd have, this would give me a negative 14 and this would give me a positive 2x. When I add them together, I get my middle term, negative 12x. So this is the process that we use for factoring trinomials. Let's take a look at the next one. I kind of wrote a little bit over it, so let me erase a little bit of what I got there. Okay, so in this case, we've got y equals x squared plus 5x minus 24. So my product is going to be a times c. And again, in all these, it's kind of easy because a is just 1. So I'm really just looking at that constant term c, which is negative 24. And then my sum is 5. So I'm looking at numbers that multiply to give me negative 24 and add to give me 5. So maybe you'll try negative 6 times 4. Well, I know that that's not going to add to give me 5. Even if I did it the other way, it's not going to add to give me 5. So how about negative 8 times 3? Well, negative 8 plus 3 is going to give me a negative 5. So what about if I changed the signs and made it 8 times negative 3? That's going to multiply to give me negative 24, and when I add, I get a positive 5. So these are the numbers I'm interested in. So when I go to factor the expression in letter B, again, I know it's going to be the product of two binomials. The first terms have to multiply to give me x squared, so I'm going to put an x in each term. Since the last terms have to multiply to give me negative 24, now I know what they are, a positive 8 and a negative 3. And when I multiply them, I get the negative 24. When I add them, I get the positive 5x. Let's do one more. In this case, we've got x squared minus 6x plus 9. The product is 9, and the sum is negative 6. So let's try 3 times 3. Well, 3 plus 3 is going to give me a positive 6. So let's think about other pairs of numbers that will multiply to give me a positive 9. What about negative 3 times negative 3? Because remember, when I multiply two negatives, I get a positive. When I add those two numbers together, I get a negative 6. So this is my magic pair. And so when I go to factor, I'm going to write my product of two binomials. I know that the first terms have to multiply to give me x squared, so x times x. The last terms have to multiply to give me 9. So we figured out that negative 3 times negative 3 gives me a positive 9. And if I think about multiplying my inner terms, so my inner and my outer terms are going to give me the sum of negative 6x. And so those are the factors for this trinomial. Okay, it gets a little bit more tricky when our leading coefficient isn't 1. I'm going to show you two different methods for doing this, and then you can pick which method you think is easier. And so we're going to start off doing the same thing like we did before. I'm going to basically take a look at my product, but this time I have to include that a value. So I'm going to be looking at the product of 3 times 10, which is 30. My sum is still going to be that b term, which is negative 17. So just like before, we're looking for numbers that multiply to give me 30 and add to give me negative 17. And so I might try 15 times 2, because 15 times 2 gives me 30, but when I add it, I get a positive 17. So let's try a negative 15 times a negative 2. When I add them, I get the negative 17 that I want. So I know that these are the terms that I want. But if I go back and do what I did last time, remember, my first terms have to multiply to give me a 3x squared. And what we did last time is we did x times x, and then we'd say negative 15 and negative 2. Don't write this down, but let me show you what happens when I FOIL it back out. X times x is only x squared. X times negative 2 is going to give me a negative 2x. That's going to give me a negative 15x, and that's going to give me a positive 30. But that's not what I started with. Even when I simplify, x squared minus 17x plus 30 is not the equation that I started with. And when we're factoring, all we're doing is rewriting the equation in a different way. We're not changing the value of it in any way. So it's not going to work using the same method that we did before. So let's think about this. I know that my first terms have to multiply to give me 3x squared. So I know that one of my terms is going to have a 3x and the other is going to have an x. But if I just go ahead and plug in my negative 15 and my negative 2, let's see what happens. Now I get my 3x squared. But when I do 3x times negative 2, I'm going to get a negative 6x. This is going to give me a negative 15x, and this is going to give me a positive 30 when I multiply. So I end up with 3x squared minus 21x plus 30, which still is not what I started with. So we've got to figure out a different way. And like I said, there's two ways that we can do it. The method that I have here in the instructions is to use a grouping method. Basically, what we're going to do is rewrite the original equation, but instead of writing the middle term as negative 17x, I'm going to rewrite the middle term using these two numbers. So I'm basically going to stretch out my equation. So it's going to start with 3x squared, and it's going to end up with the plus 10. But instead of writing negative 17x, I'm going to use these two numbers that I found, the negative 15x minus 2x. Now I have four terms in my expression. One way that you can do this is to use a grouping method. And so what I would do is I will group my first two terms and my last two terms. And so if I take a look at my first two terms, I want to look for the greatest common multiple. What number or what factor divides evenly into both of those terms? And this goes back to what we did at the very beginning of the lesson. Well, both of these expressions are divisible by 3 as well as an x. And so if I factor the 3x out, I'm left with an x minus 5. I want to do the same thing to the next pair of numbers. I have to be very careful, though, because that is a negative. And so if I want to pull out a number, I've got to remember I'm pulling out a negative number, which is going to change the sign of the 10 when I do that. So I'm looking at the negative 2x and the 10, and I realize I can pull out a 2, but I'm actually pulling out a negative 2. And so when I divide out a negative 2, this term is just going to become x. Think about what happens when you divide 10 by negative 2. It changes it to a minus 5. And this is now what I have. Notice that these expressions are the same. We can do the same thing that we just did, factoring out a common expression. Since both of those terms, so this is one term, this is another term, because terms are separated with addition and subtraction. Since both of those terms involve the same factor, I can factor it out. And so I'm undistributing it, and if I undistribute, I'm going to get x minus 5 times the quantity 3x minus 2. And now, if I check to make sure that I factored correctly, because remember, whatever I do, I want to make sure when I multiply it back out, I get what I started with. So I get my 3x squared, If I multiply x times negative 2, I'm going to get my negative 2x. This is going to give me a negative 15x. And then my last terms are going to give me a positive 10. And when I simplify, I'll have the 3x squared minus 17x plus 10. And since that's what I started with, I know these are the correct factors for that expression. Now, I told you that there's another method you can use. If this is a little too confusing for you, there's another method called the slip slide divide method, where once you get your magic numbers, what we do, this is an alternative, and if it's easier to do it this way, use whichever method works. Since I know I need to have a 3x squared here, what we'll do is sort of break it down like we did before. We'll do a 3x and a 3x. But we got to keep in mind we have an extra factor of 3 that we're going to need to pull out and make disappear. I know that I've got the negative 15 and the negative 2, so I'm going to go ahead and plug them in. But remembering that I have that extra factor of 3, because obviously if I multiply these two terms together, I get 9x squared, not 3x squared. So I have to pull that extra factor of 3 out of one of these expressions. So I'm going to look for the expression where I can actually divide both terms by 3. And this is the one that allows me to do it. And so if I divide both terms by 3, I'm going to get x minus 5 and 3x minus 2. And notice it's identical to what I got when I used the grouping strategy. You can use whichever method is easier for you. It doesn't matter. It's going to produce the correct answer either way. So I'm going to do one more example with you. We'll do the 3x squared plus 11x plus 10. Let me just give myself a blank slate to work with. Okay, so we're going to start off the same way that we did before. We're going to look at our product, a times c. So this is my a, this is my c, and 3 times 10 is 30. And then my middle term is going to be a positive 11. I'm looking for numbers that multiply to give me 30 and add to give me 11. So I might try 15 times 2. I know that doesn't work. 3 times 10, that doesn't work. What about 6 times 5? The sum equals 11, so I know those are my magic numbers. Let's use the slip slide divide method now, because I do think that sometimes can be a little bit easier. So because I've got the 3 in front, that means I'm going to just start off doing 3x and 3x. But I've got to remember I have an extra 3, and I have to pull it out. So if I go ahead and do the plus 6 and the plus 5, I've got to remember to get rid of that extra 3. So think about which expression will allow me to divide out the extra 3. And the first one allows me to do it. And so if I divide both expressions by 3, that means I'm going to be left with x plus 2 times the quantity 3x plus 5. The grouping method that I used in the first place is really helpful because we end up using it again with polynomials. So it does introduce another form of factoring that we'll be using later on in the year. But you can use either method to help you. Go ahead and try the last one. We think about our product is going to be negative 8 and our sum is going to be 7. And so if we think about numbers that multiply to give us negative 8, I might try negative 4 times 2 or negative 8 times 1. And if I add, notice here I get a negative 7. So let me switch the signs and try 8 times negative 1. When I do that, I get the 7. I'm going to go ahead and factor this expression using the grouping method just to give you one more shot at that. And so what we're going to do is we're going to rewrite that middle term using the 8 and the negative 1. So we've got 2x squared. We've got plus 8x minus x. And then I've got a minus 4 on the outside. And now I'm going to group. And so if I think about the first pair, I can pull out a 2 and an x. I'm left with x plus 4. In the second group, there's really not much I can pull out, but because I've got this minus sign here, what I'm going to do is I'm actually going to divide out a negative 1. And when I do that, if I divide out the negative 1 from negative x, I'm going to be left with a positive x. And if I divide negative 1 out of negative 4, I'm going to be left with a positive 4. And now I think you can see that those two expressions are the same, and I can factor that expression out. And I'm only factoring out one factor of x plus 4, so I'm not going to square it, even though it looks like I'm pulling out 2. And what's left is 2x minus 1. So I hope this was helpful in figuring out some of the methods for factoring. you have an assignment to go ahead and complete for the summer that will review each of these methods.